Okay, so I'm going to be taking a bit of a break from trying to work on the camera because it's been such a pain that I really need to do something else to keep my sanity. I decided to start working on the Hall effect sensors. So I mentioned last time that we had attached some Hall effect sensors on the outside of the bell of the brushless motors, but they were digital Hall effect sensors, so they were useless because they weren't getting triggered. So originally when we were first doing that, we were intending to write our own ESC code, or rather make our own ESCs from scratch, so that we could actually control the motors at low RPM so we could get the torque that we needed. But that was before we actually ended up testing these motors and seeing how they performed. So afterwards, just by testing them on normal ESCs, we realized that we don't really have to worry about the low speed torque, because at least with this gear reduction, I think it's a 4-to-1 gear reduction, after the motors will start spinning, which they'll do during the competition anyway, because you're never going to stop, you're just going to be going at some constant velocity. These motors are never going to get to such a low RPM that they lose a lot of the torque. So I think I'm going to axe the complexity of trying to include 3 Hall effect sensors for each, or 1 for each phase, and instead just have 1 so you can measure the rotational velocity, and then we can just have a simple closed loop control system to keep the motor spinning at a desired speed. So I wasn't too sure how this would fare, because the issue we were having was that the magnetic field on the outside of the bell wasn't strong enough. So we're getting a similar issue now. So originally I was testing this on plus 12 volts and ground. So that was giving me a DC offset about 6 volts, and the actual peak-to-peak waveform was only a few hundred millivolts around that. So I think we're going to have to add a negative voltage rail as well. So I've got that set up right here. So we have 5 volts and negative 5 volts, and then we have ground tapped in between them. So that gives us right now, it's idled at 140 millivolts. So you can see that as I start increasing the throttle, but yeah, so thankfully we can actually detect the revolution of the motor this time. So you can see we're getting about 300, 380 millivolts peak to peak. So that should be measurable enough. But that means that we're going to have to figure out a way to get a negative voltage rail as well. It shouldn't be too hard. So I was planning to use a Schmidt trigger inverter to act as an oscillator, and then you can use this layout of diodes. Basically, as the Schmidt trigger oscillates, you end up with an AC coupled signal on the node after the first capacitor and between the 2 diodes. So all the positive AC voltage goes straight down to ground, the negative voltage conducts through the diode, and it charges this capacitor with negative voltage, which gives you the negative output. So it should be relatively simple, but I don't have any proto board with me right now, so I can't really do anything with that. So for now I'm just going to be trying to figure out a way of mounting these Hall effect sensors. And I do, on note of the camera, ideally I would like to use the OV5645 sensor that we have. It'd be pretty cool if I could get that to work, but it's being a lot more problematic than I had originally intended it to be. So I do have an OV5640 sensor, which did cost about £50, which I'm not too happy about, but we don't have the time to deal with this anymore, so yeah, I had to go out of my way to get that. Otherwise, things should be good. I'm going to be getting to work getting the Hall effect sensor mounted, or one for each motor, and then I can think about how I'm going to be setting up, or where I'm going to be placing all the circuitry as well. Ideally, we would want this to be as balanced as possible, because we don't want the center of gravity to be in front or behind the axle. So I'm going to have to try and figure out a way of fitting in the voltage regulation circuit in this back portion as well. But that again shouldn't be too hard. But yeah, I'm going to get to work on the Hall effect sensor.